Anyway, we shall get started. So welcome to the Erlang All the Things, which is a terrible way of saying that this is a panel on IoT and the beam. For those of you who have been living under a rock for the past 5 years or haven't tried to raise money in Silicon Valley, IoT is Internet of Things, right? So we have this esteemed panel. So one by one, would you guys go and start introducing yourself? Frank, shall we start with you?
Sure. My name is Frank Hunleth. I helped create the Nerves project. So some of you might have used it before. It basically takes Elixir to make it easy to build and deploy on different devices like Raspberry Pis or BeagleBones and other industrial hardware. I also have written quite a few open source libraries for interacting with that hardware. I currently work at a company called SmartRent, where we use Nerves on devices that get deployed inside various parts of rental properties to do either access control or other kinds of monitoring that the landlords and property managers might want to do. So.
Oh no, it's me now. So my name is Amos King. I'm the CEO of Binary Noggin and founder. Some of you might know me from, I'm a host on the Elixir Outlaws podcast. I spent 13 years in the Air Force fixing electronics and fell in love with electronics. And then on happenstance, met Frank in Florida and learned all about Nerves and got really excited about the possibilities of the beam running on devices. And then I worked with SmartRent and have done some Nerves things with Schneider Electric, and they have some really neat stuff. So I guess. Oh, hey. It's my cousin, Andy King.
Well, thanks, Amos King, for that introduction. Hey, everyone, Andy King here. As far as we know, no relation.
No relation, I don't think.
Yeah, I don't think so.
We both have glasses, though.
We do.
Sometimes.
I'm just not wearing them right now, yeah. So anyway, Andy King here. Really thrilled to be here. Thank you. And thanks for the invite again, Randall. So I run the IoT capability at Slom Consulting, part of a global team. We incubate new technologies and so forth. And so we get to see a lot of really interesting things, no pun intended. And so when we look at where the market is going when we see where the market's going and where the opportunities are, I think that there's such a fantastic opening here that is going to be worthwhile conversing about. I also teach at Northeastern University, the Connected Devices course, which is also affiliated with the book I wrote with O'Reilly Media called Programming the Internet of Things. And I'll turn it over to Boyd. Boyd, over to you.
Hi, I'm Boyd. Let's see, so CEO, founder of Crichton. I spent a long time at Microsoft. 15 years of that was on the Xbox team. Got to be involved in projects like Xbox Live and XNA and Xbox One. And from that, you learn that, consoles are actually devices. They're not really PCs. They're managed like devices. They have security issues like devices. And then post-Microsoft, that led to what's now a 6-year journey exploring what would it mean to build a security-first operating system that is aimed at embedded and fully embraces the beam and helps move forward our transition to connected devices that are everywhere, but we can believe in them.
Hey, thanks for that. Actually, before we get started and we sort of dive into this whole thing, how many people here are currently working in an embedded context or have worked with devices or hardware? Can't spell geek without EE sort of thing? Okay. And how many want to or wish to? How many people have been waiting 6 months for a Raspberry Pi 4? Okay, that's most of us, right? And just so we also know, how many of you are terrified by the idea of a GPIO pen? Or terrified by electronics? I always am. That's how you let the magic smoke out. I fried more boards this way, right? Just so we kind of understand where people are coming from. Because I think one of the things that you've got to fundamentally understand is that we like to think that hardware is very different, but I'm pretty sure some of the conversations we've been having is that hardware and software are very much coming towards a convergence. So given that framework, and given we have some people who are clearly working in an embedded context, some people who would like to, and some people who just can't get in our Raspberry Pi, why the beam, why IoT devices, and specifically, What makes this different than every other group of people who's like, no, I'm going to fix embedded programming? Because I think we've seen a lot of attempts over the past 5 to 10 years. So why the beam and why now? Oh, esteemed panel, don't answer all at once. Come on.
This is why you started Nerves, right? So
Yeah, I just saw I said in the right place, and everyone just turned to me. So I guess I want to start with a few things, and one is what's embedded. I think that this field is incredibly broad. So like what I say on what I see in my little piece of embedded that I work most closely with is going to be different than, say, what Boyd and the other people on the panel say. It's different from what some other people see with using little small microcontrollers to do some little sensor nodes and stuff like that. So the field is very broad. I think it's broader than everyone, thinks when they first look at it. And there's another part of it that's important, which is that things are being networked. They've been networked. The IoT part has been networked. There's a lot of intelligence that's being moved to the edge, where these nodes are. Sometimes you just can't run this computation just centrally on a server. You want to move some code there too. And then the third part that I want to say is just how much different kind of software that you are running on these nodes. So like all of a sudden it used to be, a long time ago, it used to be that I work on a team and we'd code basically the whole project. And now it's just like take this third-party library, this other third-party, and so on. And you put all those together and the beam is in a pretty nice place. Number one, the whole fault tolerance of the beam. So just starting where I left off, which is the need to put all these third-party libraries, some others code on it. Well, now there's a framework for how it fails, how it recovers from failures. That I think a lot of us are very familiar with that, and that's kind of a nice property to have. The consistency across the ecosystem is also really nice when you're pulling in some other piece of code. You know if it fails, it can only explode so far, and then the next layer back, being able to code. If you have you're programming, normally you do back-end programming or whatever, you need to, for whatever reason, it is necessary to run that piece of code that you wrote on your device. Well, do you want to blow up that device? Like, if you're afraid of GPIOs, which you really shouldn't be. That's like another tangent, but you really shouldn't be. But you can run on the beam, and there are protections.
Wait, don't fear the I/O pin?
Well, when you could buy Raspberry Pis easily, I just suggest buy like 3 or 4
3 or 4 years
break
ago?
them, because it's just easier to break a couple and get over that fear.
Yeah, don't break the build means something completely different in hardware land.
Yeah, maybe stay at low voltage. I guess we had this at the puppeteering one with, you don't want to get hurt. But yeah, so anyway, I don't want to talk the entire time. But
you said stay at low voltage, and it's funny because that seems kind of scary to a lot of people, but really, like, what I think is awesome about Nerves and Crichton Chaos and all, like, putting the beam on these endpoint devices is that there's so much of it is exactly the same as being a web developer. Like, I've been a web developer, I've been an embedded systems developer. We're just developers, right? Like, at the end of the day, we're moving things around, we're causing things to communicate, and the tools that the beam gives you to build out these endpoint devices that are connected, and now in this world where these small Linux computers that you can buy cheap that allow you to communicate, and we get to take all of these advantages that the beam gives us in that restart time, right? Is when you do have failure, when you're trying to do that and handle it in C, and you have a lot of work to do to make sure that these pieces are able to still run whenever you have problems and not have to restart. Restarting these machines takes a long time. They don't have a lot of compute power, and so it takes some cycles. And so, like,
That's a really good point. I mean, if you think about the beam and one of the things that Elixir and Erlang gives us, who here is actually switches or works between different languages? Do people actually work in more than Elixir and Erlang on their day jobs? Okay, who here misses supervision trees every time you've got to go use something? Like two hands up, right? So you're right. So the funny thing is, one of the things I'm taking away from it is it gives you a really great set of abstractions that, strangely enough, work in so many different ways. So Andy, I don't know. So when you start thinking about like IoT devices, you've worked on a lot of these projects for clients. So why Beam? What is it about the Beam, or what is it about Elixir and Erlang that you think match up well with IoT devices?
Yeah, I guess do a.
And speak into the microphone, sir.
I gotta speak into the microphone here. Sorry about that. So I think everything my colleagues are saying is spot on. Really, let me take a step back and say the frustration, right, is anything that we do at the edge, at least for now, is mostly bespoke. And that bespokeness is actually pretty scary, especially for a developer that's trained to build things, deploy things, and manage things in a cloud environment. It's pretty easy, right? If we're going to the cloud, then, oh man, within like 5-10 minutes, I can be pretty productive, and I can use the languages I'm already comfortable with and so forth. As soon as I have to deploy something onto the edge, which is arguably more important because that's the source of our telemetry, that's where we have to verify that the information that we're actually streaming up to the cloud is correct and accurate and meaningful, all bets are off because that bespokeness. And I think that's the challenge for developers. That's the challenge for modern cloud developers that actually need to learn this. And the Beam gives us a platform where we can eliminate or at least start to mitigate that fear, uncertainty, and doubt. So I'm really excited about it. I am actually just learning this ecosystem. I've been a Python, Java, C#, C++, C developer for a long, long time. And I am just thrilled to be on stage talking with you all about the importance of moving towards the Beam and actually deploying that in some of our stuff. So excited about it. Boyd, over to you.
Yeah, Boyd. Why Beam?
Why Beam? So when I started this journey, I asked myself a couple of questions. One was, I kind of said what I wanted in entertainment, and I wanted to figure out what was the biggest impact thing I could do. And decided that it was about enabling everyone else to succeed at solving the problems that they were going after. And there's lots of movement in the web, there's lots of movement on PCs, and it's pretty clear that the next wave of devices that's coming is smart things that are hooked up in the real world. But each of those things does a job, and that job tends to be worth more than the thing itself. So you look at it a little bit and you realize, well, what are the things you care about? You care about uptime, because if it's not up, it's not doing that job, right? When you look at a factory, if a device in the factory goes down, they think of downtime in terms of dollars per minute, right? Translates directly into cost. When you think about impact in whatever field you're in, these devices have to work, they have to be programmable, and the bespoke thing is exactly right. You may have 1 million devices that all look the same, but they get put into deployments that are all slightly different from each other, so they have to be changeable. So when I started looking across the ecosystem and familiarizing myself with new languages and new VMs and all that, I wrote a little bit of code in all these different languages, and I finally got to the Beam, and it just blew my mind. Because this is a system that was put together for uptime, right? Let's not pretend that all the world's code is going to be perfect. Let's embrace that errors can happen, and let's put ourselves into a system where those errors, crashing is a feature, right? Where those errors are accepted, and it's all about rebooting very quickly and getting a machine back into a known good state. So the things that worked in the telephone industry which is why the OTP and Beam were created, are the exact things that we want on machines that are doing a real-world job. The things that are keeping the water pump going that delivers water to your house, or the things that deliver electricity to your neighborhood. Those things all need uptime, they need resilience, and the Beam's just a really good fit. The other beautiful thing of the Beam that kind of got me all excited is there's already a community of people that know it. And maybe they know it in building websites on Phoenix, but it turns out that the systems that you've learned and the languages that you've learned means that you're already an embedded developer. Because if we do our jobs right and make it so these systems run on these devices so you don't have to think too hard about it, then we're basically taking a huge community of people and making it so that they can go and get involved in embedded right now and start making practical, real devices. So I personally am all in now. I think that the time for the beam on devices is absolutely right now. It's the right piece of tech. It's got the right properties, and it's got a whole ecosystem of people that's ready to go. And it's super exciting.
So that's actually a good point. So one of the things I heard was about skills and people. So I'm going to put you on the spot here. So as somebody who might have created and been one of the people leading one of these projects in the Nerves project, so tell us about how you see that community of Nerves developers, or what are the things that you've seen in the community of Nerves developers that...
So I was going to speak up because this is probably one of the funniest unexpected things that happened to me with working on Nerves is just running into so many people who I know use Nerves. Some of my coworkers use it on a day-to-day basis and will tell me to my face and to others that they're not Nerves programmers, and they don't think of themselves that. The skills that you all have, I'm sure that many of you probably wouldn't even apply to a position that said Nerves, possibly. But a whole lot of the skills, in fact, almost, I don't know what the number is, but a large majority of the things that you do in the back end or in other programs that you write transfer very directly.
Actually, here's just a quick crowd survey. How many people here are working on some sort of Phoenix or web application or API? Is that... So it seems like a good majority. And for most people, is that the reason, like your initial entree into Elixir and Erlang was to sort of use Phoenix? So escaping it. Okay, how about this? We're going to get really, really raw here for a second. How many people were escaping a bad Node code base? Trick question. There is no good Node code base. Rewriting a Ruby app. Failed to write a Tokyo and understand Tokyo async. It's a Rust joke, sorry.
Are we doing jokes now?
Jokes are always appropriate.
Don't open this up.
I'm buying whiskey for groans. So, but no, so that's a real point. So one of the things you're saying is like, this is skills transference. So who else was talking about skills transference? Actually, so you said that you're coming to this ecosystem, right? So you were saying you've been mostly working in Python, C, C#, right? Did your skills translate when you were moving to build IoT systems, say, from between Python, C# or?
Sort of. I mean, I've always worked close to the metal, so for me, that translation or that migration really wasn't so much a migration. It was more of a slight revectoring, if you will. But I think for those that are accustomed to building native apps or cloud native apps, writing Lambda functions or whatnot, I think that they will find working in an environment like the Beam provides is actually going to be that next logical step to get them working closer to the metal without the fear, the uncertainty, the doubt, and so forth of being an embedded developer. I think to Boyd's point, we really, in the world of IoT, we're all embedded developers. We can't escape that, and we should frankly embrace it. And I think we have the tools to do so.
Here, think of it this way. I would say in the past, when you built an IoT device, you had to worry a lot more about the hardware. Exactly which chip, exactly which buses, exactly which tools are you building. And part of what the Beam brings when you're, and I don't care which OS it's running on, when you're coding in the Beam, you don't have to worry as much about the specifics of the hardware. Effectively, what we're trying to do is turn IoT and hardware projects into software projects.
Well, that's a really good point. I think that's also interesting because if you think about embedded toolkits, generally speaking, are, I don't know if you guys have ever shopped embedded, but normally they start at thousands of dollars and go up from there. And then the open source alternatives, generally speaking, haven't been so, well, they're interesting. They're just normally not very easy to use or user-friendly. I have to say, Nerves is probably one of the, you guys teach Nerves courses, and you get people who, generally speaking, aren't embedded developers, like building devices in a day, right?
Yeah, that's the general audience for the Nerves classes are coming from Phoenix, coming from others. We definitely get some people curious from industry to go to that, but yeah, it's a lot of the getting started is not too hard with the Beam. A lot of the skills are very familiar with Phoenix. With the addition of, there are probably a few more gen servers and supervision trees that you look at with Nerves versus getting started with Phoenix. But I pick that as more the hurdle than the actual hardware.
Okay, so great. So we're happy. So why aren't people using the Beam? Why isn't okay, why isn't nerves more successful? Why aren't we all seeing cars running on nerves? And why haven't people been adopting it with such...
It is successful. Like, that's the big thing that I keep running into is okay, web developers out there for years have talked about what they're doing constantly online, talking about what they're doing, and the embedded community has been either tight-lipped or just didn't really discuss it much. And it's still kind of that way. Like, you have companies like Schneider Electric that they don't look at, it's not an advertisement for them to talk about, oh, we use nerves, so they don't. It's an advertisement for them to say, hey, we have this device that stays up all the time and will keep your company running even when power's not going well. The people buying that don't care that it's powered by nerves, so they're not talking about it. And that's one thing that we need to do, anybody who is working in embedded, is start talking about it, be loud about it. And really, like, if you're touching nerves at all, you're an embedded developer, whether you like to admit it or not.
Commentary?
I want to pop it up a level.
Sure.
It's not a question of why isn't the beam being used on embedded. I think we can go further than that and say, is IoT actually achieving the success that we were all promised? When I look at the numbers and I think about 10 years ago when we were talking about IoT and how it was going to be everywhere, I don't think IoT is succeeding. Right? IoT in general has not achieved the potential that it could, and I think the potential that it will. So when I look at it overall, there's a set of root problems that need to be solved, and the beam addresses one of those, and that's the uptime one, the automatic recovery, the self-healing. But there's also a giant security problem, and there's also a giant manageability problem, and all three of those have to be addressed together. And the beam, I think, is a crucial piece of that story, but it's not the entire story. Just example, I've been touring factories and talking to manufacturers, and they are freaked out about security, right? So I think that's a critical component. So it's less, why isn't the beam being used on embedded? It's why aren't people embracing IoT, connectivity to servers? They're scared. I mean, it's not safe yet.
I think you're right. And really. All right, so let's think about like a house, for instance. I mean, when you look at a house that has everything that you're looking for bedrooms and bathrooms and kitchen and the right flow and everything. The last thing you're thinking of, unless you're an engineer, maybe that's what I think about first. But anyway, unless you're really thinking about how the structure of the building is put together, the plumbing, you're not paying attention to the stuff that actually makes the building function the way it's supposed to be functioning. And yet, we also don't pay attention to that in the IoT. And I think that's the fundamental problem that we've run into is it's because it's hard. It's hard to do plumbing well. It's hard to do electrical well. It's hard to make a foundation that actually can work in, different types of soils and deal with the runoff and everything like that. So these are difficult engineering problems, but I think as we can resolve those and actually make the security easier to manage, the management of the device, firmware updates and whatnot, easier to manage, and of course the runtime easier to manage, then I think we're going to see the IoT actually take off. Because I'll tell you, the last thing that I want is a bunch of devices that are running like a bunch of generic code with all kinds of dependencies and so forth that I have no idea, right? And then worry about whether they're getting updated properly and then having to be responsible for maintaining those. That's, I think, one of the fundamental challenges that we have.
So that's a really good point. How many people here are freaked out by the recent OpenSSL issue? Okay, how about this? How many people know that their thermostat is probably running something that's it's going to be easily like cracked because there hasn't been a firmware update? Every time like there's like a Heartbleed style attack, I'm always like checking firmware update for my router, and I'm always really depressed when it's like weeks go by before I can get a firmware update for a router.
Yeah. So how many of you are afraid to actually go to your favorite department store and actually buy the latest smart device and just deploy it in your house because it happens to work? Yeah, it's like everyone's raising their hands, right? I don't have any of those. All the stuff in my house is like custom made, and all the software is custom because I know what's in it.
I'm pretty sure this group probably VLANs things off, though. No? Okay, see, there's always somebody back there. Okay, so you're talking about this ecosystem. You're saying this is part of it. So what's missing? What are we currently, so given where we're at, given where we're thinking like, okay, there's a really good match for Beam and devices and for Beam languages on these devices, where are we not making things either as accessible? What could we be doing better? What are the things that we need to be approaching or looking at doing better? Oh, I see. What are we?
Look at Frank.
Yep.
You get a lot of feedback.
I think that there are a couple answers to this. It depends on what device you're building, because obviously if the library doesn't exist for the device that you're building, well, of course, that would be probably one of your top choices. So generically, what could we do better? Well, the things that I look at for the NERVS project, documentation, very solid ways, good routes to get started, right? You can make a lot of progress with the Beam. Takes a little bit more to get over the edge and make a deployable device as you start to come up to speed with like all the little details that you have to do to actually get that thing in the field and not be a nightmare to maintain. How do you structure code? I would say that documentation would be the first number one thing that I would pick on, is where, and many of us do work on that, but it's certainly an endless task. There are jumping back for libraries, other kinds of things that we need. I totally would echo everything that's been said about manageability, security. Firmware updates is a nonstop thing. No matter how much time you put into it, it seems like there's always another one. And then you find out that the hard way these are not easy problems. There's a lot of work that goes on behind the scenes.
I want to add something. So Frank and I are attacking this from slightly different perspectives, but one thing I think is really important is that we have some APIs at the Elixir level that are identical, right? Like, I really like the circuits APIs, and if I want people who are building devices that you can think about your business logic, you can think about the logic of what the device does, you can go build it out on one system, maybe you build it out on a different system. How it actually gets deployed then depends on where you're putting it, what are the threat models, what are the specific scenarios. But it's important that the skills that you've learned as an Erlang or an Elixir developer translate across different projects and different devices.
Right. It's hard for me to communicate sometimes how complementary all these embedded projects are. You think, Erlang community is so big. Do our projects compete? Does GRISP, Chaos, a lot of these things, do they all compete on the embedded systems? And the answer is no. The field's broad.
So for those who don't know, GRISP is actually a raw Erlang VM on hardware.
Right.
So I think it's grisp.org.
Yep, grisp.org.
And Pierre, I can't pronounce his last name to save my life, but it's a great project. It was on Kickstarter. So if you're looking for a way to run a raw Erlang VM.
Yep.
And I kind of haven't gone into like full on what I'm building, but that's tomorrow. So, right.
But it's even more than that. Some people just run the Erlang VM just on a regular, Ubuntu or Debian OS. Like, they don't do anything. They just go that route. There are a lot of ways to be successful in this field, and there are different things that when you're looking at your project that might be very important or not, and that can help guide. But
I think something that we're all really on the same page about is that we're trying to turn embedded into a software project. And we think that the skills that everyone's been building on Elixir and Erlang and Phoenix are directly applicable to a whole new range of projects. And as far as we're all concerned, we just want to make sure that when it comes to embedded, that we all realize that the Beam is not a four-letter word.
No.
But it technically is a four-letter acronym.
He got it in there. He's been talking about that.
So actually, wait, how many people here work for like a consulting company or do project work? Some? Oh, actually not as many as we would think. So for you guys, I think one of the other things that's important, I'm going to address this to Amos, which is what does it mean to be able to take the same guys who are building Phoenix projects and then put them on a hardware project?
Thanks for chipping that up to me.
Oh, yeah, we know.
He knows what I want to say. So like being able to move from project to project quickly is really nice, and taking those skills from one to another. And with IoT, we're all connected anyway, so it's just like making front-end connected web apps. Like we've been making single-page apps and live view apps that communicate over these ports, and we can do the same thing with those devices. So taking that same skill set where people have learned and in the community that's been sharing a lot, that web community, and porting that over to devices is really important. But also you get to create a single team that works on one thing, right? If they're working on the IoT or the server, it's the same people. And the same people, now like I'm talking to anybody who owns a business out there now, is now you have reduced your communication overhead and the cost of communication, and Conway's Law, if anybody's ever heard of that, where your software mimics the communication structures of your environment. Like if you want these endpoint devices to behave as like all part of one system, then maybe you should try to have one communicating team and all working in the same technology so they don't have to do context switching constantly.
So that's actually a really good point, Frank. So it's really interesting because I think I got one of your devices that we were looking at, and the last time I was kind of blown away because it's now controlled mostly and configured to be a live view interface, right?
The Nerves Livebook, yeah. So Nerves Livebook was one of the best surprises, I think, that came from the community that just, Jose and Yunat, and that it just worked with Nerves. And I actually want to take a step back and just ask who's looked at, if you've looked at the Beam and looked at the source code to the Beam, many people have actually looked into it. Maybe you've cursed some of the choices that were made in the Beam, but on the whole, I think that I've been using this for a long time. The choices are really good. Every time that I've actually hated a choice, I think a year later or something, I've learned something really important about the wisdom that went into this. And this has transferred to a lot of the work that we've gotten to build. And I think this is one of the reasons why a whole bunch of us are just devoted to pushing this technology forward as a good platform for these devices that we put on the field. It's solid, and I think through some experience, we've definitely learned this, sometimes the hard way.
So I have a question. Someone is still new to this ecosystem, and I think it's what you were saying, Amos, about the teams kind of communicating better, working together, and so forth. Can you talk more about your experiences with the standing up full stack teams to actually build Nerves applications, full stack teams, like front end through back end?
Okay, I'm going to change it up. I'm going to change it up just a little bit because this is really important about bringing people from other communities in, I think. And we were able to take a team that was all C developers and embedded systems developers and put them on a platform and teach them Elixir in a very short period of time. And this team still is doing Elixir and Nerves today, and they have Phoenix running on the thing, so they have like a whole web stack, and they're doing the front end work, and it is. I want to say it's 4 people on that team. I'm trying to think back. It's been a couple years since I worked with them, but so they have a team of 4 who's doing everything from like the server, the website, the front end. They probably even need to use less stuff now that Live View is around because they don't need to know as much JavaScript to do that. They're doing the bit banging, and like that's actually a really amazing feature of the Beam. That pattern matching on bits makes taking a data sheet. Does anybody not know what a data sheet is?
Did anybody here take C or embedded systems programming in college? And remember how you had to set those masks? You have to figure out X, F, is it big Indian, little Indian, and then you shift, and then and then you get the mask wrong, and then you can't figure out what it is, and then it's unsigned, that crap. Yeah, pretty much that's true. I would actually use Erlang or Elixir just for the bit term syntax.
Oh yeah, because then you don't have it, like that stuff. Even when I see it now, and I've done it enough, but I still see it and I have to stop and think, and that's time lost. If I have to stop and think about something in order to make it happen, that's time lost. So I want the tools to be an extension of the way I think and the things I'm reading. So if I'm reading a data sheet and it has some binary output and says it should be in this order, I just want to write that binary output, and that's what the pattern matching does for you. So it's taken all of the mystique out of having to that you have to learn to be an embedded developer, thrown half of it away.
You were going to say?
I was going to say, I've been talking to a bunch of manufacturers lately. Some really big ones, some really small ones. And there's one question that I hear repeatedly from all of them, even though they've got a variety of different concerns. the one question I always get is, how am I going to hire people who know how to build embedded on a new system? And the answer is that by choosing the Beam as the preferred application interface, we've already got a huge community of people, right? And part of the opportunity that I want everyone else to hear is we're talking about bit banging, that's all pattern matching. We already have these skills. These are skills that are hard for embedded people to do today. And we're bringing a set of skills from Elixir and Erlang and Phoenix and all that. And this is a huge market that's opening up. I mean, we're talking billions of devices are going to get made, and they need the skills that this community has already built. Right? That's part of my takeaway from the investigation and even listening to the conversation.
Yeah, that's a really good point, because I think it's really interesting that if you've written C, it doesn't help you write C++. And depending on which version or which year of C++, it actually doesn't help you write C++. Right? So, and if you've written one embedded system, it's really hard to move to another embedded system. Like learning like one set of microcontrollers or one set of abstractions, generally speaking, does not directly translate unless you have a really expensive toolkit that helps you do that for you. So that's a really good point. So, okay, so we've got just a couple minutes before we have to wrap up. So I'm going to sort of open up the floor and basically say, okay, so what's the one takeaway? You're speaking to the audience. We've got fairly captive because we all know that you guys don't get to drink until you finish listening to us, right? So, so we can basically all get to the bar and continue the Q&A. What's the one takeaway? So we'll start with you, Frank. What's the one takeaway that you want to leave people with when they think about the Beam and IoT?
Well, I just want to echo what's been said here, that embedded's accessible. It's totally accessible to anyone. Don't be afraid of this. Hopefully you can get maybe double the hardware that you need so that you can break one, and then understand that they're actually harder to break than it seems for a lot of the things that you probably want to do. And just try it. Like, you'll be amazed at how many of your skills transfer. So.
The hard part of developing for embedded is not learning about how to talk to a device. It's with IoT and we're talking to the cloud, you are generating a denial of service attack all the time. You think that a lot of users can create a lot of data and a lot of requests for your server? Imagine a whole bunch of robots doing that. So that's actually the hard part, is the server side, and it's a whole lot of fun in the Beam. So you hop in, just try it.
Yeah, I think the one takeaway for me is, and again, to echo what everyone else has said, is really about democratization. And the cloud did that, right, for development, software development in general, and scale and so forth. I want to do that in embedded, see that happen, and see this community actually come into its own, and more people join it. So that's what I'm excited about. That's the takeaway for me.
Good segue. I was talking to Neil, who's back there taking notes. And we had this observation a couple weeks ago. It feels like right now, we're in this spot that feels like it did in around 2000 as the web was coming. You could see that it was going to change everything. You could see it was coming around the corner. People were just starting to wrap their heads around it. That's where embedded is, right? It has not hit yet, but it is going to. And the skills that are needed is going to be a tremendous demand. You said it exactly right, that it's not a deployment of 1 million machines that all are identical. It's 1 million deployments of a couple machines that all have bespoke configurations. And there is a tremendous need for skills, for people, and for accessible languages and runtimes that have good uptime. And it feels like it's got the excitement that it did around 2000 as the web was coming. And I think this is an incredibly good time to be working on the Beam. It's an incredibly good time to be learning these skills and having these skills. And I really honestly think this is going to be like the next 20-year wave.
All right. So we're going to, okay, we've got time for one question because we need to be on time. Please, go for it.
Asking for myself. Supposing one wanted to start an IoT startup, what advice do y'all have for that?
Suppose one is wanting to start an IoT startup. What advice do you have for that? I'm going to go back and say create one team of developers that all use the same technology.
See, I'm going to say, come find me when we're drinking beer, give me 5%, and I'll tell you everything you want to know. But then again, I've been in Silicon Valley longer than you, so my morals are suspect.
I would say you need to be really crystal clear about what problem you're solving and what's the job that machine is going to do. Because it's not about the machine and it's not about IoT. Actually, I hate the name IoT. It's not about the device, it's about the job the device does and being really clear on it and what's the value it delivers.
Yeah, I'll pull on that thread. My first question is, why do you want to start an IoT company? But more importantly, where do you want to actually live? Where do you want your technology to live? Do you want it to be the full stack, or do you want to live like in one particular niche area? And so very much related to what Boyd was saying.
Actually, so hold on. We can't do this without getting Frank. You get the last word. So, as somebody who actually has started an IoT company and works in these devices, what would you say?
This is such a long conversation. If I get the last word, I want to take. I want to possibly
So in
switch
other
up
words, I
right
think the
here.
answer there is track down Frank in about 5 minutes. So thank you so much for your attention, and thank you for sort of coming to this panel. We will definitely be available for other further questions and continue talking afterwards, all right? So, and I want to thank all the sponsors of the conference for both not only giving us this opportunity to meet, but definitely for also paying for all the beer. Thank you so much.